Imagine you're an architect, but your next project isn't a skyscraper or a cozy home. No, your client wants a house built somewhere with no air, wild temperature swings, and a constant blast of deadly radiation. Sounds impossible, right? Well, let's get into it because we're talking about the ultimate architectural challenge, building for space. And what's really wild is how these out-of-this-world designs might just be the key to a better future right here on Earth.
So let's just start with the big question right up front. How do you actually build a home in a place that's trying to kill you every second of every day? I mean, a place where you're not just worried about the lack of air, but also tiny meteorites and the, deep, crushing loneliness of being millions of miles from everything and everyone? That's the puzzle that space architects are trying to solve right now.
Okay, first up, we're designing for the void. Before you can build anything, you got to know the lay of the land, right? Well, when we're talking about the moon and Mars, the land is fundamentally alien, and it's not exactly friendly. We're dealing with a totally different set of rules. And this table really lays it all out. On Earth, we take our thick atmosphere and comfortable gravity for granted. Now look at the moon. Just 1/6 the gravity and basically no atmosphere at all. The temperature swings are just insane, from minus 173 Celsius to a scorching 117 degrees. Mars is, well, it's a little less hostile, but its atmosphere is still less than 1% of ours. And the big one, the real killer, is radiation. Here, we're protected by our magnetic field. Out there, you're completely exposed.
Yeah, that lack of an atmosphere is a real double whammy. It's your shield, and without it, you're getting hit with a constant stream of cosmic rays and solar radiation. And on top of that, tiny little micrometeorites, some no bigger than a grain of sand, are zipping around like bullets. So, rule number 1 of space architecture, you need a seriously good shield over your head.
So, the conditions are pretty much impossible. How in the world do you build anything? You can't just pack up bricks and steel on a rocket. The answer is, well, it's both incredibly clever and kind of obvious once you think about it. You use what's already there.
And it all comes down to this one critical idea: In-Situ Resource Utilization. I know, it's a mouthful. Most people just call it ISRU. But all it really means is living off the land. Instead of hauling everything from Earth, you learn to use the local materials, the moon dust or Martian soil, also known as regolith, to build what you need.
And if you're wondering why this is so important, well, it comes down to cost. A lot of cost. Just look at this number. We're talking more than 20,000 euros to get a single kilogram, that's about the weight of a bag of sugar, to the moon. Now imagine shipping an entire house. It's not going to happen. So ISRU isn't just a cool idea, it's the only way any of this is possible.
So what does this actually look like in practice? Honestly, it's straight out of a sci-fi movie. Step 1, the robots land first. They get to work on their own, scooping up that local dust. Step 3, they feed that dust into giant 3D printers, which start building the habitat's outer shell, layer by layer. And only then, once a safe, shielded structure is ready and waiting, do the humans finally show up. It's genius, really. Construction without ever putting a person in danger.
And hey, this isn't some far-off fantasy. Companies are designing and testing this stuff right now. Take a look at the Martian habitat from AI Space Factory. This thing actually won a NASA competition. It's this amazing, tall, egg-shaped building designed to be printed from Martian dust mixed with a special bioplastic. And that shape is brilliant. It gives you the most floor space on multiple levels with the smallest possible footprint, which is exactly what you want when every single cubic foot has to be pressurized.
Okay, so we've got our 3D printed shell. It's tough, it protects you from the vacuum and the radiation. We're done, right? Not even close. Because building a shelter is one thing, but turning that shelter into a home, that's a whole different challenge. And it's all about the fragile human mind. And this quote just nails it. The psychological impact is a critical factor. You see, you can give an astronaut all the oxygen and recycled water they need, but if their environment slowly crushes their spirit over 2 years of isolation, the mission is a failure. An architect for Mars has to be part engineer and part psychologist. I love this breakdown because it shows the two sides of the same coin. On one side, you've got basic survival. That's the stuff on the left: pressurized air, water, shielding. It's the engineering checklist. But on the right, that's where we get to thriving. We're talking simulated daylight to keep your body clock normal, private quarters for when you just need to be alone, and common areas so you can feel like part of a team. It's the difference between just staying alive and actually living.
So how do you design for the mind? It's all about human-centered design. Architects think about things like creating spaces that flow between private and public so astronauts can choose how social they want to be.
They use soft, comfortable materials instead of just cold metal. And this one is huge. They use windows or incredibly realistic virtual screens to fight off sensory deprivation. Because imagine staring at the same few walls for years on end, you'd go nuts.
So, we've been way out on Mars this whole time. But now, here's the twist, the big reveal. All this incredible innovation, this laser focus on sustainability, on recycling everything, on human well-being in a tiny, closed world, it's not just for space. It has huge implications for how we could live right here, back on Earth.
And you don't even have to leave our planet to see it in action. Look at this. It's the Princess Elizabeth Station in Antarctica. This place is a self-sufficient, zero-emission research base in one of the harshest places on Earth. And its design principles? Closed-loop systems, super-efficient energy, psychological support for the crew? Sound familiar? It's practically a blueprint for a Mars base.
There's actually a name for this whole idea, and it's called universal architecture. The core thought is really simple. Designing a building for Antarctica and designing one for Mars aren't that different. At their heart, both are about using technology and smart design to help humans thrive sustainably in extreme environments, and the lessons from one can absolutely help the other. And you can see the direct payoffs right here. Those closed-loop water systems that recycle every last drop on Mars? Imagine using them to fight water shortages in dry regions on Earth. The ultra-efficient solar power and battery storage? That's a perfect model for off-grid homes. And that 3D printing technology that uses local dirt? Imagine being able to build safe, affordable housing anywhere in the world, using the very soil you're standing on. This isn't just about space anymore. It's about bringing that innovation home.
Which brings us to this one last big question. By pushing ourselves to solve the hardest architectural problem imaginable, how to live on another planet, are we accidentally creating the perfect roadmap for a more sustainable and resilient life here on Earth? It really makes you wonder. Maybe to build a better future down here, we first have to learn how to build up there.